Welcome to our final lesson in this chapter, where I want to briefly discuss the OpenAPI specification and show you how you can use it to generate HTTP clients. This won't be by any means a deep dive into this topic. I simply want to bring it to your attention and demonstrate what's possible, and I'm going to leave you some additional learning resources if you want to explore this idea further. Before we can talk about HTTP client generation, we have to start from the OpenAPI specification, and this is something that's already enabled inside of our REST API. If we open up our DevHabit REST API and take a look at the program file, there is an extension method that we added in the past called add API services. Inside of this method, there is a call to builder services at OpenAPI. This is introduced by the Microsoft OpenAPI library, which is installed by default starting from .NET 9. This is pretty much a move away from Swagger, which was used in prior versions of .NET for generating the OpenAPI specifications, and now we have a Microsoft maintained library that should do the same thing, but it's not exactly on par when it comes to the available features. Now, this just introduces the required services into the dependency injection container. Then we also have an additional call here when we build the application, and note that this is only available in development, and this is the map OpenAPI method. What this does is it exposes an endpoint where you can access the OpenAPI document for your API instance. So if I start the application and I head over to localhost 5001, which is the root address of my application, and then navigate to OpenAPI version 1 JSON, I will be greeted by the OpenAPI specification for my REST API. You can see that this is using OpenAPI version 3.0.1, which is the most up-to-date version at the time of recording this video. Now, as our application has grown and we've added more endpoints to our REST API, so has the OpenAPI specification. There's built-in tooling that scans the available endpoints in your application and turns that into an OpenAPI spec, which is what you can see here. For example, here's the register endpoint, and we can see what is the request object, the register user DTO, that's supported for this endpoint. Now I'm going to download this file and open it from VS Code. So here is the same file viewed from VS Code, and you can see that it's a pretty large JSON document. It's more than 2,600 lines of code, and this contains the entire specification for our REST API. This includes the list of API endpoints, but also the request objects that we are exposing on the API surface. These are all of our DTOs that we are using to represent the external contract of our APIs. So what we can do with this OpenAPI specification is use it for rendering documentation UIs. I'll demonstrate this as part of the documentation section, but what I want to show you here is another use case for the OpenAPI specification, which is generating HTTP clients that can automatically integrate with the respective API endpoints and also map out all of the DTOs representing the external contract of your API. There are a couple of tools that you can use to achieve this, the most popular one being the OpenAPI generator, and here you can find the GitHub repository, which also contains extensive documentation on using this tool. Now, this is just one of the available options. We also have NSWAG, which is a .NET tool, and one of the interesting things it has is the NSWAG Studio. This is a desktop app that you can use for turning OpenAPI or Swagger specifications into HTTP clients. It also supports exporting to multiple other languages. For example, you can target C# or you can target TypeScript. So this is definitely an interesting option to explore. And one last approach I want to mention here is a Microsoft-supported library called Microsoft Kayota, which is an OpenAPI-based HTTP client generator. It also works as a CLI tool, which you can install globally and use it to generate HTTP clients. The GitHub repository includes some documentation, which you can use for getting started, but there are definitely more details on the Microsoft website, and I'm going to leave the links to the documentation right below this video. Now let's go back to our OpenAPI specification, and I want to show you how to use Kayota for generating HTTP clients. Let's open up a terminal from VS Code, and the first thing I want to do is to install Kayota as a global tool. You can say .NET tool install, specify the global tag, and then enter Microsoft OpenAPI Kayota. Now I already have this tool installed, so this won't do anything on my system, but now I can use the Kayota CLI command to interact with this tool. For example, I can check which version I have, and I can also get some help to see what are the available options for working with this CLI tool. Now what I want to do is to use Coyote to generate an API client. Here's a command for generating a C# client from our OpenAPI specification. The command is Coyote generate, then I specify a language flag. I'll say the language is C#. Then I need to specify a path to my OpenAPI specification, which is just v1.json because I'm running in the same folder. Then I'm giving a name to my client and an output location, which I want to be nested inside of a folder. So if I hit enter, we run into an exception. And this is because my OpenAPI specification is incorrect. If I look for the tags collection DTO, let me find it in this document. I have to go to the actual component definition, which should be near the end of the specification. You will see that it's referencing the HateOS links as some component that doesn't exist. And I left this in on purpose just to demonstrate that the Microsoft OpenAPI package that we currently have is still rough around the edges. So this is a typical example of a bug that you may run into with this library. If we were using Swagger, which I'll demonstrate in the documentation chapter, this would probably work as expected. Now, what do we need to do to fix it? We have to find a response that is correctly rendering our HateOS links. So let me look for links, and here is the user DTO, for example. You can see that it contains the links property, the same as our tags collection DTO, but here it's properly referencing the link DTO object. So let's go back to the tags collection. I'll skip a few of these, and then here is where we need to make the actual update. So this component is incorrect, and if I update it to properly reference the link DTO, I should be able to build my HTTP client. So let's try running the same command again. And this time you can see that it succeeds, and it does so pretty quickly. Now I can open up the C# client folder, and this contains the code for my HTTP client, which I built using Microsoft Coyote. So this is basically an SDK, which you can distribute to anyone who wants to integrate with your REST API, and it already contains the available API endpoints, how to call them, and also the respective external contract represented by your DTOs. For example, in the models folder, you will find all of the DTO definitions that we have inside of our application. Now, a bunch of this is auto-generated code, which is a bit difficult to read. And you will also see the top-level groups represented by our controllers that we have inside of our REST API. So you can see the users, the habits, the GitHub endpoints, the entries, and for each of them we have the respective API endpoint definitions represented inside of our HTTP client. So I won't be going through all of this in depth. I just wanted to demonstrate how you can generate an HTTP client and not necessarily how to use it. That's a bit outside of the scope of what I intended for this lesson. I also want to show you how to generate a TypeScript client. The command is almost identical. You say Coyote generate, specify TypeScript as the language, the path to the OpenAPI file, the name of our client, and the output folder. And I'm going to generate, and I'll get another folder here, the TypeScript client, which contains a very similar structure to the C# client, except this one uses TypeScript, and we could have integrated it into our client application built with React, which would make it simpler to call our API endpoints. This isn't something that I wanted to do. I prefer writing my own integrations, but definitely something to consider if you are exposing a REST API and you want to enable clients to easily integrate with your REST API and write the minimal amount of code. And with this, we have come to the end of this chapter about integrating a client application with our REST API. I introduced you to the DevHabit client application that was built using React, and I demonstrated how it integrates with our REST API and heavily utilizes the hypermedia links that we are returning in the API responses to drive the behavior on the user interface. In our next chapter, I'm moving the focus back to our REST API, and we are going to discuss some advanced REST API concerns.